There are a lot of videos on YouTube on the difference between deduction and induction. They are all wrong. No, I'm just kidding. They're not wrong, but they just scratch the surface and they miss out on so many juicy, philosophically juicy details that I decided to make a short video about this. Now, I'm sure you all know, maybe just vaguely, what the difference is between deduction and induction, what these words mean, generally speaking. Deduction is the move from general principles to particular cases, whereas induction is the opposite move from particular cases, usually observed ones, to general theories or general principles. That's it. In describing this, the videos are not wrong. This is true. If you open the dictionary, this is what they mean. But there is, at the same time, a problem of deduction, and I'm going to tell you what that problem is, and an arguably more famous problem of induction. So let's talk about these two. First, deduction. Let's start with a simple argument, the well-known, all men are mortal, Socrates is a man, therefore Socrates is mortal. You might look at this and say, it is deductively valid, so it is a good argument. But that's not quite how it works, because you see, validity is something that we apply to formal language. That is to say, we can only say of a move from a certain proposition to the other that it is deductively valid if those propositions are expressed in formal terms. This is why deductive reasoning or deductive logic is something that you find in math and geometry, formal logic, proof, computer science, so on and so forth. So validity is the main guy in a different movie. It's not what we use when we look at arguments. That's the first problem. I think the main problem of deduction is that it says nothing about the real world, and it is therefore not useful as an ideal of either reasoning or argumentation. The argument, all men are mortal and Socrates is a man, therefore Socrates is mortal, is expressed in everyday language. So, for one thing, it is not entirely certain, although we assume it, of course, that Socrates in the premises is the same as Socrates in the conclusion, or that man and men is the same. These are all problems of translation. Keep in mind, deductive validity pertains to logic and math and the formal sciences, which are formal in the sense that they're empty. They're not saying anything about the world. There's another, let's say, consequence of this problem that is worth mentioning. In a deductively valid argument, the truth of the conclusion is already contained in the premises. In other words, if you know that all men are mortal, and you know that Socrates is a man, you already know, within these two premises, you already know that Socrates is mortal. And that is that's not a problem in logic, because that's what you want. You want the truth to be preserved. In other words, you want the truth of the premises to be equivalent to the truth of the conclusion. Let's say we have a disagreement, and you don't know that Socrates is mortal. Now, if I manage to establish before you and you accept that Socrates is a man and all men are mortal, then we have thereby ended our disagreement. There's no need to make this performative step from those two premises to the conclusion. Now, what this means is that as a model of argumentation, deduction seems to work only when there's no disagreement. Because keep in mind, if there is real disagreement on the fact that Socrates is mortal, then my opponent cannot actually agree on the premises. So there's nothing I can do with deduction. And that is the problem of deduction. It is the main character in all the formal, or as they're called, axiomatic sciences, not in real life where we argue or we reason about real things. That's the problem of deduction. Now let's move on to the problem of induction. In most textbooks, induction is the move from particular statements, usually observations, to general theories or sometimes hypotheses or just more general propositions. So I observe this one to be white, I observe the next one, I keep observing, and I draw, it is said through induction, I draw the conclusion that all swans are white. Now, you feel that the move from those premises, those observations to the general conclusion is less strong. Your instinct should tell you that even if you've inspected 1, 10, 100, 1,000 swans and saw that they were white, this does not fully, not in the sense of deductive validity, it does not fully justify the conclusion that all swans are white. And this is, in a sense, the beginning of all the problems with induction, because there seems to be a leap of faith there. Keep in mind, the number of observed cases must not be the same as the number of cases about which we conclude. So I have to move from 100 swans to all the swans, from 2 neighborhoods to all the neighborhoods, from these families to all families, so on and so forth. This is induction. Otherwise, if I have an equal number of cases, it's just a tautology, it's just a statement of equivalence. 100 swans are white, therefore 100 swans are white is saying the same thing twice. That's what tautology means. So there's always a leap of faith. And you might say, well, what's the problem? There's a leap of faith when we generalize. What's the problem? Well, you see, the problem of induction is that for a long time, people have thought induction to be the main method of science. You see, I'm giving examples of observations and general conclusions as if I'm a scientist or biologist trying to establish something about swans. And if induction is the main character in the empirical sciences, where we want to say something about the world, not the axiomatic sciences, then it seems to force us to conclude that science is irrational. Because if there's always this leap of faith, then we can always be wrong. And isn't science supposed to be more of a certain type of endeavor? But the problem is even deeper. And I want to read parts of a famous book now in which you see that, in fact, the problem is that the induction as a method is based on something called the principle of induction. And it is the lack of clarity, but also lack of ground for believing such a principle that is the actual problem. Let's read a famous passage and then I'll come back and conclude. Okay, so this is the first chapter, actually the first section of the first chapter of The Logic of Scientific Discovery. A survey of some fundamental problems. A scientist, whether theorist or experimenter, puts forward statements or systems of statements and tests them step by step. In the field of the empirical sciences more particularly, he constructs hypotheses or systems of theories and tests them against experience by observation and experiment. I suggest that it is the task of the logic of scientific discovery, or the logic of knowledge, to give a logical analysis of this procedure, that is, to analyze the method of the empirical sciences. But what are these methods of the empirical sciences? And what do we call empirical science? The problem of induction. According to a widely accepted view to be opposed in this book, the empirical sciences can be characterized by the fact that they use inductive methods, as they're called. Wink, wink, Mr. Carnap. According to this view, the logic of scientific discovery would be identical with inductive logic, i.e., with the logical analysis of these inductive methods. It is usual to call an inference inductive if it passes from singular statements, sometimes also called particular statements, such as accounts of the results of observations or experiments, to universal statements such as hypotheses or theories. Now, it is far from obvious from a logical point of view that we are justified in inferring universal statements from singular ones, something we talked about. Induction is never deductively valid and rational in that particular sense, no matter how numerous. For any conclusion drawn in this way may always turn out to be false, no matter how many instances of white swans we may have observed. This does not justify the conclusion that all swans are white. The question whether inductive inferences are justified or under what conditions is known as the problem of induction. The problem of induction may also be formulated as the question of the validity or the truth of universal statements which are based on experience, such as the hypotheses and theoretical systems of the empirical sciences. So the problem of induction is that if this is the method of science, then all science is irrational or not wholly rational. For many people believe that the truth of these universal statements is known by experience, yet it is clear that an account of an experience, of an observation or the result of an experiment, can in the first place be only a singular statement, not a universal one. So we want to say about science that it is based on experience, but when we describe experience, we don't describe at that level of generality. We don't describe hypotheses and theories. We describe singular cases or particular cases. Accordingly, people who say of a universal statement that we know its truth from experience usually mean that the truth of this universal statement can somehow, a bit of irony here, can somehow be reduced to the truth of singular ones, and that these singular ones are known by experience to be true, which amounts to saying that the universal statement is based on inductive inference. Thus, to ask whether there are natural laws known to be true appears to be only another way of asking whether inductive inferences are logically justified. So again, the status of scientific knowledge hangs or stands or falls with the status of inductive logic. Yet if we want to find a way of justifying inductive inferences, we must first of all try to establish a principle of induction. A principle of induction would be a statement with the help of which we could put inductive inferences into a logically acceptable form. This is what we mean by making an inductive inference logical from a deductive point of view. That is to say, putting all the extra assumptions or filling all the gaps so that the steps are truth-preserving. In the eyes of the upholders of inductive logic, wink wink, Carnap, a principle of induction is of supreme, or Reichenbach, yes, is of supreme importance for scientific method. This principle, says Reichenbach, determines the truth of scientific theories. So this extra that we add to make an inductive inferences or an inductive inference correct or logically correct. So this principle, this add-on, you could say, this principle determines the truth of scientific theories. To eliminate it from science would mean nothing less than to deprive science of the power to decide the truth or falsity of its theories. Without it, clearly, science would no longer have the right to distinguish its theories from the fanciful and arbitrary creations of the poet's mind. Very nice, very poetic. Like I said, it stands or falls with this principle of induction. Now, this principle of induction cannot be a purely logical truth like a tautology or an analytic statement. So now Popper is saying, okay, then we need this sort of saving principle of induction. But what is it? It cannot be logical truth or an analytic statement. Indeed, if it were such a thing as a purely logical principle of induction, there would be no problem of induction. For in this case, all inductive inferences would have to be regarded as purely logical or tautological transformation, just like inferences in deductive logic. So this thing that we throw, this buoy, this floaty that we throw to save induction and turn it into something like deduction cannot be from the principles of deductive logic, cannot be an analytic statement or a tautology. A tautology like A is A, or any logic equivalence in formal terms, something self-evident, in other words. Thus, the principle of induction must be a synthetic statement. That is a statement whose negation is not self-contradictory, but logically possible. So the question arises why such a principle should be accepted at all, and how we can justify its acceptance on rational grounds. Some who believe in inductive logic are anxious to point out, with Reichenbach, that the principle of induction is unreservedly accepted by the whole of science and that no man can seriously doubt this principle in everyday life either. Which is what Popper will do. Yet even supposing this were the case, after all, the whole of science might err, I should still contend that a principle of induction is superfluous, and that it must lead to logical inconsistencies. That inconsistencies may easily arise in connection with the principle of induction should have been clear from the work of Hume, and here he quotes the pages from a treatise concerning human understanding. I always confuse Hume and Locke because the titles are similar. Yet even supposing this were that inconsistencies may easily arise in connection with the principle of induction should have been clear from the work of Hume, David Hume. Also that they can be avoided, if at all, only with difficulty. For the principle of induction must be a universal statement in its turn. This is crucial. If we are to help induction to become rational, this help must come in the form of a synthetic, universal statement. Thus, if we try to regard the truth as known from experience, then the very same problems which if we try to regard its truth, so the truth of the principle, as known from experience, then the very same problems which occasioned its introduction will arise all over again. To justify it, we should have to employ inductive inferences because we just decided it has to be a synthetic universal statement. So how are we going to justify it? Well, we seem to need an inductive principle of a higher order and so on. So to justify it, we should have to employ inductive inferences, and to justify these, we should have to assume an inductive principle of a higher order and so on. The problem of ad infinitum. Thus, the attempt to base the principle of induction on experience breaks down, since it must lead to an infinite regress. Kant tried to force his way out of this difficulty by taking the principle of induction, which he formulated as the principle of universal causation, to be a priori valid. But I do not think that his ingenious attempt to provide an a priori justification for synthetic statements was successful. My own view is that the various difficulties of inductive logic here sketched are insurmountable. So these are real problems. The problem of induction is real and unresolved. So also, I fear, are those inherent in the doctrine, so widely current today, that inductive inferences, although not strictly valid, can attain some degree of reliability or of probability. According to this doctrine, inductive inferences are probable inferences. We have described, says Reichenbach, the principle of induction as the means whereby science decide upon truth. To be more exact, we should say that it serves to decide upon probability. For it is not given to science to reach either truth or falsity, but scientific statements can only attain continuous degrees of probability, whose unattainable upper and lower limits are truth and falsity. Not clear how the lower limit is unattainable, because you can clearly say something very, very false. But anyway, I'll let that slide. At this stage, I can disregard the fact that the believers in inductive logic entertain an idea of probability that I shall later reject as highly unsuitable for their own purposes. He comes back to that later. I can do so because the difficulties mentioned are not even touched by an appeal to probability. For if a certain degree of probability is to be assigned to statements based on inductive inferences, then this will have to be justified by invoking a new principle of induction appropriately modified. So what he's saying is that you're not getting away with it. If you say, well, deduction is not rational in a deductive sense. Did I say it correctly? Induction is not rational in a deductive sense, but it is still kind of rational because you reach with it only probable conclusions. And then Popper says, okay, but then in order to reach those conclusions, even if you now lowered the bar and called them probable, you have to have this principle of induction, okay, maybe not from singular to universal, but from singular to probable or partial or some other form of statement. So maybe the content of the principle changed a bit, but the arbitrariness of the principle, or in any case, its lack of justification, is still there. It's the same problem. It's not less of a problem. It's just that it's a different problem. And this, sorry, did I say that correctly? It's not less of a problem. It's just that it takes a different form, this time pertaining to probability. And this new principle, in its turn, will have to be justified, and so on. Nothing is gained, moreover, if the principle of induction in its turn is taken not as true, but only as probable. In short, like every other form of inductive logic, the logic of probable inference or probability logic leads either to an infinite regress or to the doctrine of a priorism. I think that's how you pronounce it. The theory to be developed in the following pages stands directly opposed to all attempts to operate with the ideas of inductive logic. It might be described as the theory of the deductive method of testing, or as the view that a hypothesis can only be empirically tested, and only after it has been advanced. Before I can elaborate this view, which might be called deductivism in contrast to inductivism, I must first make clear the distinction between psychology of knowledge, which deals with empirical facts, and the logic of knowledge, which is concerned only with logical relations. For the belief in inductive logic is largely due to a confusion of psychological problems with epistemological ones. Okay, he goes on to make this distinction, and then he says, well, I'm only interested in the logic of scientific discovery. I'm not interested in the psychology of scientific discovery. So if you know Popper's work, you know that he goes on to say science is rational because it is deductive. Science is rational not because of some principle that we then have to try to uphold or support some way or the other. It is rational because of what happens to a statement, universal or not, what happens to a statement after it has advanced. In other words, I don't care where the statement comes from, he says. It can come from intuition. It can come from previous statements. It doesn't matter. I'm assuming they're all equally good or equally bad. What makes science rational is its method, is its way of dealing with statements, and that is trying your best to falsify that statement, to set up an experimental setting where that statement, if false, is disproven. And the lack of success in disproving the theory is then equivalent to its acceptability. So now let's summarize. Let's go back. Deduction offers us all the strength and the certainty that we want, but it does not touch upon reality. Induction, on the other hand, does have this, let's call it, contact with reality. However, it does not have that feel, that certainty that we would like to attribute to science. Now, Popper's way out in his debate with Carnap and in the inductivists is to say, and Reichenbach, is to say that, but don't worry about it. The method of science is an induction anyway, so the weakness of induction doesn't plague science. Science is a deductive endeavor because you try to falsify something. You try to contradict your own predictions or refute your own predictions. And that is what makes science rational. Now, for those of you who stayed until the end, let me give you an extra insight. You see, this idea that we can, at least in principle, know the big structure of the world, that the world is put together in such a way that it is rational, and because we are rational, we can capture it. This idea is not self-evident, and in fact, it is, starting with the 19th century, the main point of attack for a group of philosophers we now refer to as Romantics. Romanticism was an attack upon the Enlightenment and the statement that the world is rational and that there is one world, so to speak, universal, necessary, and rational and accessible to all. This claim has been attacked in various ways and mainly from the German side by the Romantics. So maybe I suggest one book. There's this book called Whose Justice, Whose Rationality by Alistair McIntyre. And it shows that rationality is as much a matter of style as any other practical endeavor, such as, I don't know, architecture or maybe art or maybe styles of speaking or interacting with each other. Of course, modes of rationality change a bit more slowly. It doesn't change like fashion every 5 years, what it means to be rational. Although, let us note that the way in which Trump, for example, is portrayed as extremely irrational by some group and extremely rational by others might point out to precisely that we're living precisely this kind of change from, I don't know, you can call it truth to post-truth, whatever. I don't even care who's right. I just want to signal the fact that there are clear differences in perceived rationality. Another example of this change is that if you go back to, let's say, Plato's dialogues, you will discover that a lot of the reasoning going on there is not very rational. And that was the pinnacle of rationality for an entire generation, and you could argue for an entire culture. The same with the writings of medieval philosophers. Take, for example, the writings of Augustine. He also wrote dialogues, but even in the letters that are not dialogical, he was trying his best to approach Christianity from a rational perspective. And yet, if you read it today, they're not that strong. The arguments that he puts forward do not hold water in the sense we would expect a philosopher to argue today. So in this book, Whose Justice and Whose Rationality, McIntyre looks a bit at the history of this concept of, in this case, justice, but the adjacent concept of rationality as a cultural product. And this means, to wrap it up, this means that to speak of reasoning and to speak of science and to speak of a good argument in universal terms is maybe something that we should treat with a bit of suspicion, unless you are a pre-19th century thinker. Let me know what you think, and let me know if I should explain anything else. I'll do it in the commentary. I'll promise to comment section. I promise to read all the comments and answer them. Don't forget to subscribe. Thank you.